what I want to show you guys today for organic chemistry is going to be the reaction scheme question. Like the identification test question, there's no easy way for me to teach this, and the SciPad doesn't have set sections to kind of cover it. It does have pages that do talk about the different types of reactions, so addition and substitution and elimination reactions that might be helpful as understanding the reaction itself. But the best way I think to learn this question is to just do it by practice. The other main thing about this question is that you're going to really need to memorize all the various conversions, so that's why I want you guys to have those resources open today while we're learning. You will not be getting this on the assessment, so you do, like I said, need to have them memorized. So let me just open it up so you guys can see the documents that I'm talking about, which is there's flashcards for No Brain Too Small that you can use for today, or while you're learning, I should say. There we go. So it goes through and it tells you how to convert from one organic molecule to another. The other thing that I provided that I can print out for you guys if you want is a blank, not useful that it's upside down. Can I flip this around in this document? I think if you press edit PDF. Oh wait, no. Oh, it's sideways. All right. I have another idea. Let's download it. And I know when I open that itself, I should be able to rotate it. There we go. All right, that's better. Yeah. Easy solution. Okay. So, I provided both of these for you guys. You will not get this on the assessment. You do need to have these reactions memorized, but for today's lesson, for just learning it, we are going to use it to help us. Okay? We good? All right, so let's look at these flowchart questions. So right here, this is one of the style questions that you can get on the assessment, which is also known as a reaction scheme. They do ask this in two different ways. So once I go through this one, I'll show you guys the other way they ask it, and that's going to be the next lesson, basically. So first off is that they basically give you a scheme, and they give you some of the information, but not all of the information. My first suggestion for you guys is to annotate the information, so that way you kind of have an idea of what's supposed to be doing what. I'm not going to do the Achieve, Merit, and Excellence color code because you'll see in the marking schedule it's just a matter of how many you get right. So for example, if I want to go through and think about functional groups, the first one here that I have is an alcohol. The second one over here, I have an acid chloride. This one over here is an ester. And then this one down at the bottom is a ketone. So the reason why I suggest you go through and annotate what you have is so that way it can help you access the knowledge in your brain. Because when you think about the different types of reactions, you're going to be thinking about it like, oh, alcohol going from this to this, etc., etc. Next thing I'm going to annotate is the reagents and what they do. So I'm just mindful that this needs to be memorized. I actually don't have them memorized off the top of my head, so it's good. I'm doing it the same way you guys are doing it. So for example, this first one I see says dilute sulfuric acid. So if I go onto this sheet here, I can look for sulfuric acid. It's really important whether or not it's dilute or concentrated because that changes what's going to happen reaction-wise. So, let's see, we have heat with concentrated sulfuric acid. That's not what I want. Let's keep looking. It's concentrated. Where's the dilute one? Might find the word dilute. Oh, can I not search that? That's irritating. I know what I need. Okay, so this one, again, is not obvious. So I'm sorry, but it's helpful to see this. So you see how this has H plus and H2O on there? Let me give you the notes, ladies. I recommend getting your device open. There are two documents that I suggest opening up. All All right, fifth one is not obvious, but I am using my knowledge to help me figure out which one I want. So, do you see here how one of my products is an alcohol? And you see how one product is making two things? So that hints to me that I'm going to have to be using, I think it's, adding it. Is that Markarnikov or Zaitchev's? I'm trying to remember now. Alkene to alcohol, need H2O. Breaking the double bond. Yeah, so Zaitchev's rule. Rich get richer. So, do you see how I see there's two products here? So that's already hinting, whenever I see two products or like major product, it gives me a hint that you're probably using Zaitchev's or Markarnikov's rule. Do you understand my thought process to how I got there? I see head nodding. I'm checking other eyes. Julia's looking a little confused. Yes? Hey, sorry, Markarnikov's rule. Thank you. Got it the wrong way around. I don't have them always memorized the right way. So, I see also here it says dilute sulfuric acid. The other thing that you can see when you're calling it dilute sulfuric acid is basically you are just dealing with hydrogen ions and H2O. So that is just acid mixed into water, so that is dilute. So when I look at this card here, it says you're going from an alkene to an alcohol. You see how I got that answer? No? Okay. So on the sheet here, you see how it says dilute sulfuric acid? So dilute sulfuric acid could also be thought of as hydrogen ions and H2O because you have acid mixed into water. So I'm just translating that into another format. Okay? When I go look at my card here, it says that this is an addition reaction. So I'm adding something to my molecule, and I've started with an alkene. So if I backtrack from the alcohol to this previous product, this must be the alkene. Are we good with how I got there? Does that make more sense? Serena, does that make more sense? Don't just give me a nod because you just want me to stop picking on you.
Wait, but it's true. There's either alkene or alcohol.
What are you talking about?
So how do I know which one?
So we figured that out. So when you're looking at this information, good question. So you see how there's an alkene to, are you talking about which one?
I'm talking about this.
Alkene to alcohol.
Yeah, how do you know which one it is?
So I know which one it is because this here is the alcohol.
Because it's a product of...
Yeah, it's the product of it. And then this is my sulfuric acid, which is dilute. So that tells me it's just a weak acid. Like it's just acid here.
Yeah, that makes sense.
All right? So you have to have these reactions memorized, unfortunately. Otherwise, this is going to be a real pain in the butt to figure out. So if I backtrack and I go, okay, this here's an alkene built off of this molecule, then what I must do is I need to remove the OH and remove one of the hydrogens and build the double bond. So the product here is 1, 2, 3, 4 carbons. 1, 2, 3, 4. There's a double bond between carbon number 1 and 2 because that's where the OH has come off of. That's how I've gone backwards. You don't need to fill in the flowchart in order. I'm just doing it in that way because what's my thought process in there? I'm just doing it that way because that's what I can figure out. Are we okay with how I got to that point? All right. Now, I can figure out compound B from this information as well, because if I know I am doing a dilute sulfuric acid and it's addition reaction, this is where I'm now going to be adding Markarnikov's rule, which is the rich get richer. Do you see how we're thinking about that? So in this case, this is the hydrogen that's rich, that's the hydrogen that's poor. So this one should be getting the extra hydrogen, and this one should be getting the OH. When I look at this product here, it's happened the other way around, so that's my minor. So this is my major. So you see major, minor, it hints to me that we're using Markarnikov's rule here. So then what this compound B is this one with the alcohol on the other carbon.
The poorer carbon.
The poorer carbon. Okay. I'm just looking at it. It looks weird. That should be the answer. Then why is this the next product? Hold on, guys. Let me just have a think. Let me start that back up. All right. I'm very, very wrong. I was misreading the question. This is a lesson for you guys, not to jump into the question without thinking about everything first. Because when I was doing that, I realized, okay, let me backtrack. I started doing this molecule here. I thought this is Markovnikov's rule, which is a good guess of what you think could happen because the dilute sulfuric acid would be able to do that reaction there, that addition reaction. However, when I wrote that product down, it didn't make sense to the next product that was being formed.
Why?
Why? Let me draw what it was again. So I had CH3, CH2, COH, HCH3 like that. There was no way for me to get this molecule to that molecule. Because you see how in this second carbon here, there's a methyl, and there's an acid chloride. So there was no step that would have gotten me from there to there. So that was what told me I did something wrong. So, lesson learned, do not just jump in and start answering the question until you've actually read the whole thing and figured out what's actually going on. Okay? That was my bad. All right, so let's erase this. So if you guys got some twink, please twink out my mistake. It's a very good learning experience for you because you can see I make the mistake. And they made this a really hard question, which I do not appreciate.
Yeah.
No, I try to understand what they're trying to do. All right, let's go through and annotate the rest of it. Because I am not impressed with that. All right. I'll come back to that one because actually it might make more sense to work backwards. Okay. Another thing we see here is concentrated sulfuric acid. So let's find that on our sheet. I'm just going to move that. That was the answers. Here we go. All right. So we are looking for concentrated sulfuric acid just on its own with heat. That is acid, concentrated sulfuric acid with an acid fluoride, sorry, carboxylic acid. That's one with the alcohol. So that's not what we want. That's up here. Have I uploaded this? Yeah, it's on my Google site. Google site, there's no brain too small conversion flashcards, and there's a blank reaction scheme. So there's two things here to help us answer these questions, okay? Let's see. Here we go. Concentrated H2SO4. It's a dehydration elimination reaction. You're going from an alcohol to alkene. So when I go back to this sheet here, this is an elimination reaction. And we're going from alcohol to alkene. Are we good? Glasses on would help. All right. This one I can easily make because this one I'm just working backwards. This is what I had here on accident. So if we are doing an elimination reaction, we are moving the OH and we're removing one of the hydrogens and putting the double bond there. So the answer to this one was actually what I wrote up here. CH3. That was the other reason why I noticed I was doing something wrong. Cool. All right, we happy with that? All right, now there's another hint in this question, and it says compound C to compound D, you want the major product. So that tells me that from here to here, we are going to be using Markovnikov's rule. And we have to think about breaking the double bond. And when we break that double bond, you are going to be adding to what is expected to be the major product. So the rich should be getting richer. Okay? Are we good with that? Now, before I write that down, because there's lots of major minor products that happen with addition reactions. So just as a reminder, when we're looking at these addition reactions, you could have an alkene to an alcohol, you could have an alkene to a haloalkane, you could have an alkene to haloalkanes. Basically, it's the reactions in yellow. You can have an alkene to an alkane. So there's lots of options that could happen there. Are you guys getting that okay? Boys, I know you're trying to explain it to each other, but can you please like stop talking because it's not helping the rest of the class? Thank you. All right, I know, Xander, you probably already figured it out. You can move on to something else. Okay, you haven't figured it out. Okay, then listen to me. All right, so do you see how there are like 4 different possibilities for for the addition reactions that we've identified? So I need to figure out which of these 4 it is. And so what I need to do is look at the reaction scheme and see if I can work backwards to get another hint. I see that product D is supposed to go from D to a ketone. So if I was to work backwards, what makes ketones? Not a double bond. It's an alcohol, secondary alcohol. So I know that product D needs to be a secondary alcohol. So what that tells me is that the addition reaction I'm doing is going to add an OH. Do you see how my brain made that logical step? And unfortunately, you do have to have these memorized. So, because I know that this ketone is a secondary alcohol, and it will verify with compound C what's going down here. So I should have CH3, CH2, COH, HCH3 as my product there. Because when I do Markovnikov's rule, the hydrogen's going to go on the rich carbon, and the poor carbon's going to get the OH. So that checks off with this. And then this ticks off with this, because if this gets oxidized to a ketone, the double bond's forming on carbon number 2, which is where the alcohol's at. So those all tick off to each other. Do you guys see that logic? Hopefully. Serena, you're not giving me much on your face, so I can't tell. Does it make sense or no? No? Okay. So we have to combine knowledge from all of organic chemistry. So it's a really steep learning curve to understand what's going on. All right? So that's why I've been annotating it and using that to help me figure out what's going on. So first thing I notice is that this is an alcohol. Second thing I notice is that this is concentrated sulfuric acid. So based off of the memorization of these reaction schemes, these conversion reactions, I can figure out what the next product is. So when I look at the concentrated sulfuric acid that starts with an alcohol, it is, where'd you go? We're just here. Here. Alcohol to alkene. Concentrated sulfuric acid, dehydration, elimination reaction. You have to have these memorized. This is why I keep saying organic chemistry has a really steep learning curve, but the moment you get these memorized, everything else is really easy because you don't actually have to write anything to get the excellence. You just have to answer the flow chart because that's requiring logic. And that's how you're getting your excellence points. So do you see how in that case, because I have the alcohol to the alkene, I know this is the reagent there, I have figured out how I'm going from here to here. Okay? Next thing I need to figure out is what is compound D? So I'm going to use the hints around me to help me figure out compound D. So the first hint that I have is a ketone, and I'm thinking, how do I make ketones? So again, we look at our flashcards, or we can look at this flow chart here that I have, and ketones are over here. And you see how ketones can go here from the alcohol. And it says a secondary alcohol forms a ketone. And again, if I go look at my flashcards and I look for ketones, let's see if I can find you easily. Might not be an easy thing to find because this is not always ideal. Where are you? Ketone, ketone, ketone. Here we go. Secondary alcohol to ketone. You need heat with either dichromate or permanganate, and that's an oxidation reaction. So if I was to go to this guy here, and I was working ketone backwards, the only thing that can make a ketone is a secondary alcohol. So that's how I know this product here must be that. So I can work backward from this molecule to figure out this molecule, or I can work forward from this molecule to figure out that molecule. It's probably easy to work backwards, because if I have a ketone, and I'm reversing it back to a secondary alcohol, ketones, we just remove the double bond from the O, and then we add the hydrogen. That's how we make our alcohol. Yes.
Is addition always Markovnikov's thing?
And then elimination should be Zaitos. I never seem to have it always memorized, so that should be it. Are we okay with that? How I went backwards. Now, if I want to double check my answers, let's go forward to make sure this makes sense with that one as well, because they all should fit in together like a puzzle. So we know we have an alkene here, and we're thinking about this reaction here. So when I look, if I'm going from an alkene to an alcohol, we are looking at this reaction here, alkene to alcohol. So that's why that guy's coming in here. Now, when we do that reaction, because it's not symmetrical, I'm going to get two products. So when that double bond breaks and it adds the OH, and then the other component would be the hydrogen can either go on carbon number 1 or carbon number 2. So we're looking at Markovnikov's rule. So we have to keep on top of all of our chemistry because that's unfortunately how externals are, because it builds on its stuff. That's why I'm saying organic has a steep learning curve. So what it tells me down here is that you want the major product. So you want the more common product. So the rich should get richer. So the carbon with the hydrogen is more likely to gain another hydrogen. So when I break this double bond, this should go to 3 and the OH should go here, which is what I have here. All right? And that verifies what I have down here. So everything should make sense logically as an order. Now that I've confirmed all these products, I can then identify what reagents I need. So this again is just memorization. So when I think alkene to secondary alcohol, we look on our list on what we need. It says you need hydrogen and H2O. Let's add that to our reactions. So H plus and H2O for that reaction to occur. And then in this case, I want to see how do I go from a secondary alcohol to a ketone. Let's check that sheet. Where'd you go? Where'd you go? Here we go. Secondary alcohol to ketone. You need heat with dichromate or permanganate. It's your choice. Both will be marked as correct. So I'm going to do permanganate. Plus heat. You do need to have that specification on does it need heat, does it need pressure, does it need this. Like you need to have the catalyst. Now they want me to, oh, sorry, that should go here. Forward arrow. Don't do silly stuff like that. Be better than me. Okay, this one here is going in reverse. So if I want to go from ketone back to a secondary alcohol, how would I do that? Again, got to have these memorized. So we are looking for the reverse of that reaction, which I believe is down here. Ketone to secondary alcohol, it's a reduction reaction, which makes sense because the forward reaction is oxidation, so the reverse must be reduction. And you need to have NBH4 in alkaline conditions, so in a base. Is it B? BH4. Are we okay with that? All right, now let me work through the nasty part because they did not do that very nicely. Sticking an ester in there. They'd suck in 2 esters. Not that that's a very nice thing to do, but it is what it is. All right, are we okay with that? Organic. Yes? Organic, yes, better-ish. You got to have these things memorized. All right, so next thing we are working on is our esters. Just love this question. All right, you see here how you have your acid chloride. Here's your ester, and you're trying to pair up the different components. So remember, esters are made up of carboxylic acid, or you can do an acid chloride and an alcohol. All right? So when I look at this molecule here and I look at this molecule up here, this came from that guy up there. So basically, what's reagent 2 is this guy over here. All right, so let's look at how acid chlorides become esters. Again, we'll look at our little flashcards. And we're looking for acid chloride and esters. Actually, I think we're up here. Yes, so, oh wait, that's the backward reaction. We want the forward reaction.
Is it the brown one? Let's go.
That one's going alcohol to ester.
Another one if you scroll down.
Oh, this one. Ester.
Page 2, yeah.
Oh, here we go. There you go. All right, acid chloride to ester. There we go. All right, so all we need to do in that case, oh, that's very, oh, there we go. Add the alcohol that is required. That's it. So when I look at this reaction here, I just need to draw this alcohol. So this is 1, 2, 3, and the OH is on carbon number 2. That's all. Do you want me to backtrack? Okay. When we are making esters, they are either a carboxylic acid and an alcohol or the acid chloride and the alcohol. The acid chloride is the same thing as a carboxylic acid. The only difference is that you have a Cl instead of an OH. So that makes it really, really reactive. So you don't have to add any extra reagents to it. So when I look at this product here, I can see that this component is from the acid chloride. And the other component I need for the ester is the alcohol. So I've taken this bit here, that's coming from there, and then that's my alcohol. And so that's my reagent, is the alcohol. Because when I mix the alcohol with the acid chloride, I form the ester there. Okay? All right, keep going. You guys hate it, it's okay. All right, cool. Now, I understand what we're doing up here. Okay, so this is an alcohol, correct? This here is an acid chloride. So before it was an acid chloride, it was probably a carboxylic acid. And if I add a carboxylic acid with an alcohol, I am back to an ester. So that's why I was like, this is a very mean question. They put the ester twice. Usually they only put the ester once. So this here is a carboxylic acid most likely. And then this up here is going to be an ester. Backtracking. I started in the wrong spot and that was why it was really hard. So don't feel like because it's written this way, you have to answer that way. You can start anywhere and work your way around. It's a flow chart. All right. So this guy, when I go back to this guy, what I can do is I can basically undo this Cl. I want to double check that it is a carboxylic acid. So let's just find ester to, like how to break down an ester. This is ester hydrolysis. So we are starting with an ester. Hey, hey. Where is the ester? Ester. Here we go. Ester. Do you see? Ester going to an alcohol and carboxylic acid. You heat with an acid, which they have done, dilute sulfuric acid with heat. So I was right that that is a reagent. It's just wrong reaction when I was thinking about that. So still, that one is the same as saying that. Cool? So this I know is my carboxylic acid, so I write this molecule down here. I just swap out the Cl for an OH. Like that. And then I put these two guys back together. So this here, when we're making our esters, remember the OH is coming off, or sorry, the H is coming off, what am I doing? OH is coming off here, H is coming off here. I am not impressed with this question. They have given you guys some really hard ones that I'm like, Especially because like post-COVID and stuff, I was like, why are you guys being like extra hard? So there is there, and then I'm writing this basically backwards. So this is my alcohol. 1, 2, 3, 4. 1, 2, 3, 4. That's the OH. OH.
Where did the H go?
The H was eliminated. And the OH here was eliminated. So that way they can link together. And then this was copied from there. Yep. This is why you gotta memorize your things. As I said, it's a really steep learning curve. Let me tell you how the points break down, because then you're gonna be like, oh, actually it's worth me trying to learn this. Okay. All right. Carboxylic acid to acid chloride. Let's find that guy on our list. So we want a carboxylic acid. It's chloride. Salt. It is a substitution reaction, I believe, when it's classified. And I put it on. Oh, there it is. Carboxylic acid to acid chloride. You need any of these reagents here. So SOCl2, PCl5, or PCl3. All those would work. So basically what we're trying to do is substitute the OH for the Cl. And the reason why we do that is because the acid chlorides are very reactive. If I wanted to go from carboxylic acid to ester, I still could. It's just going to require extra reagents. So let me show you where that is. Carboxylic acid to ester. Here you go. Heat with alcohol and concentrated sulfuric acid to make that. So there's another way to get there. It just requires different reagents. All right, let me show you guys how the points work out, because I think it's going to help you realize that, yes, this is really difficult, but once you do that steep learning curve and you memorize everything and you know how these flow charts work, it's going to be a walk in the park. So that's what I said. Organic chemistry is really hard to get the achieved on, but really easy to get the excellence on. It's very bizarre like that. All right, let me show you the answer. Okay, so this is the answer to question C. It says any 5 answers give you an achieved point. So when we look at the question script, there are, let me try to color what I haven't used. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 questions. You have to get 5 out of 9 for the achieved. That's what I'm saying. It's it's really hard to get achieved on these things, I find. Because if you don't know, you just don't know. You don't even know how to get started. All right. For the merit was 7 out of 9. And then 9 out of 9 is excellence. So if you can fill in this whole table correctly, there is no writing, E point. That's it. So that's the trade-off between organic and thermal chemistry. So a lot of the organic questions, the excellence point doesn't actually require you to write explanations. It just requires you to show that you understand the process. The downside is it's a really steep learning curve to learn that process. And it's really hard, like I said, to get achieved because it's actually quite difficult because you need to actually understand quite a bit of it. Thermochemistry, because I know some of you guys are still on the fence. Boys, thermochemistry, because I know some of you guys are on the fence. It's easier to get an achieved on because you can rote learn things. You can learn the structure of the answer. The other thing with thermochemistry is that there is going to be a math component to it. So there's essay writing and math. So that is not ideal for a lot of people. All right? With thermochemistry, it is easier to get the achieved, but harder to get the excellence because they are expecting essay explanations. So you have to ask yourself, what do you want to do? Basically, pick your poison. There's pros and cons to each one. This one's harder to get started on, but once you get it, it's pretty easy. Thermochemistry is easy to get started on, but hard to get your excellence. So keep that in mind when you guys are trying to pick which one you want to do. All right? Sorry the notes went on for so long, but I just want to get you guys thinking about this. So let me give you guys some advice on what to do next, because I'm moving on to basically a Mahi choice. Are there any questions about this? No? Okay. Like I said, the SciPad doesn't really cover the flowchart itself as a learning section. What it does do, and it might help you guys to start off with. All right, so the SciPad doesn't have a set section on organic chemistry, but it does do pages like Markovnikov's rule, which is an elimination reaction, which is what we were talking about here. Oh, no, Zaitchus is elimination.
Yeah, you said.
Oh, yeah. Sorry. Yeah, that doesn't have Zaitchus because it's similar. Sorry. Not symmetrical. Okay. So you see how it goes through and it gives you different reactions? Let's see, is that the end? No. It's naming them, classifying them, Lucas reagent. There's a lot in here that's not actually useful. Like this here is more so more so a thermochemistry question than an organic question. That's why I'm very mindful of what I actually tell you to do in these books. So, like for example here, addition reactions making alcohols by hydration. So it does cover stuff in the flowchart. It might actually be useful as a beginning kind of step because it gives you that foundation information without jumping into the whole thing. I'll go through and I'll try to identify which pages I would recommend if you want to do like the baby flowchart stuff. But the problem is you can't really teach this bit. You just kind of have to keep doing it until you learn it. So that's kind of the challenge there. Anyway, I'll find the SciPath pages that correspond. But for my recommendations for what you guys do for the remainder of today's session, I know there's not a lot of time left because that took longer than I thought. So, several choices with the Mahi choice. The first thing is to use the flashcards or Quizlet to memorize all those reactions. I'm happy to print out those flashcards if anyone wants them. The other thing I would suggest you do that's really useful is filling in a flowchart as a summary notes. So for example, with this, let me go back to the document camera so you can actually see what I'm talking about. So for example, we've talked about alkenes and we've talked about how they can be converted to alcohols and haloalkanes. One thing you can do is you can make notes on here. So for example, for the alkene, you can make note that you know that these guys form cis-trans isomers. You can make notes on how you would name it. So it's an E-N-E ending. You can make notes going from alcohol to alkene. You are going to be doing an elimination reaction, so you should be using Zaitchus rule here, if need be. Probably spelling Zaitchus wrong. And if you're going from an alkene to an alcohol, you should be using Markovnikov's rule. So it's a really good idea for organic chemistry when learning it is to have one of these sheets here and annotate the whole thing so that way you can update it as you're learning notes. You can put in your notes here about Zaitchus and Markovnikov's rule. You can put in notes here about primary and secondary, aldehydes, ketones, carboxylic acids. We've covered some of this already. So I really highly recommend it. I do have a filled-in version of this with notes, both a student version and my version, but I want you guys to do this on your own because that's the whole idea, is that it's a learning journey. So once you guys have some of these done, I'll upload the exemplar and my version later so you can kind of see it. But it's worthwhile to just rack your brain and try to do this yourself. This, I would say, is probably the best thing you can do to learn organic chemistry because this is the whole core of what the assessment's on. It's all of these reactions. So I'm happy to print some of these guys out. I can print it in color if you want because I did color code it. So these yellow ones are representing elimination reactions. Green is representing addition reactions. Orange, I think, was substitution. Pink was oxidation. So I did color code it. Or I can print it in black and white. You can just color code it yourself. All right, so that's option number 2. Option number 3, I'll put on the SciPath pages that I would recommend as kind of like the baby pages. And then last recommendation is to work on the collated questions from No Brain Too Small. With those collated questions, let me just point something out so you know which ones you're doing. So the collated questions, these reaction schemes have 2 versions. The first version is they give you the flow chart and you're filling in what's going on. The nasty version is they don't give you the reaction scheme, but they tell you, we want you to go from propanone to ethyl propanoate. And you got to figure out how to go from point A to point B. I will cover that separately, so don't worry. So skip questions like this. These are the questions you can do. All right? Cool. I also have a CPR quiz that I was going to give you guys for homework, but looking at the state of panic on your face, I'm going to hold that off until Monday. Okay? All right. Pick what you want to do. I'll try to find the SciPath pages that correspond. If you're not sure about organic chemistry, I would say give it another week. And if you're still not for me, then you can do thermochemistry. I think a lot of you guys have the full books, so you can look at the thermochemistry stuff already, and you get a gauge on if that's more your cup of tea. All right? That's it.